Okay, welcome to Math 145, Section 2.1. Here, as it says, we are going to organize qualitative data. So, categories of things, right? Like the colors of M&Ms. That's our first example. We are not looking at quantitative data. We will look at that in Section 2.2. We are going to focus here in this section on data tables, bar graphs, and pie charts. So, the idea, as that little paragraph tells you, you're going to, once you have your raw data, want to display it, right? So, first off, let's talk about tables. Consider this data obtained deliciously from a bag of M&Ms. We are interested in the distribution of colors of the M&Ms in the bag. So, what I have here is pretend I pulled out a bag of M&Ms and we just had a brown one, and then a brown one, and then a yellow one, and then a red one, and then a red one, and so forth. And we want to talk about the distribution or the number of M&Ms of each color. Okay, so we're going to do number one. And it says, first, make a tally chart. This is the most efficient way to count repeated data. Go through the list one by one and make a tally next to each color as it occurs. Then count the tally marks at the end and place those numbers in the right column. So what I mean by that is the first one here is brown. I'll mark it off and put a little tally there. Next one is brown. Okay, tally. Next one is yellow. Right? You remember this? Maybe from some other class? Maybe from a long time ago, perhaps, right? So continue, pause me down, continue with that, and then meet me back here and I'll have that completed. Okay, so there is my work, and I just, again, continued through all of those without marking them off so you could read them better afterwards. And I ended up with 12 brown tallies, and so I put 12 into the count or the frequency column there, and of course continued down the way. I totaled them, and I got 45. The thought bubble points out that's a really good idea as just kind of a minor check to go back through the original data and actually count these and make sure there are really 45 little colors written down over here. There are, so check. All right, now next thing, let's talk about what we did. We made a table where we had the colors, the possible colors, all the possible colors, you'll notice, and how many of each of those colors we had, right? That is called a frequency distribution. So we've got a particular definition down here, and now we'll just move on to the next page. Let's step it up a notch. Let's make a relative frequency distribution, and all that means is instead of having the counts, like there's 12 brown M&Ms, there's 3 blue M&Ms, we're going to have percentages or proportions of the total M&Ms. So let's look at that definition first, of course. The relative frequency is the proportion or percent of observations within a category and is found by using this guy. And this is just that percent equals part out of whole formula that I've got rumbling around in my head. And they just, rewrote it for the terminology that they're using here. And then if I make a table with those relative frequencies, then I have a relative frequency distribution. So there's that definition. Number 2 says, let's create that. And so all I want you to do is, as it say, divide each category's frequency by the total to get each category's relative frequency. Then record those numbers in the new table below. And so let's do that. So there's 12 brown M&Ms. I'm going to divide it by the total. Okay? And then whatever that happens to be, we're going to we're going to round that to 3 decimal places. So here I go, and that looks like 0.266666666, right? If I'm going to round it to 3 decimal places, I'm going to look at the fourth digit. Let's actually review that. Round 0.266666666. It just keeps going, and then it finally gets a 7 at the end on the calculator, doesn't it? So to round to 3 decimal places, I'm going to look at the 4th decimal. That is that 6 right there. And it's 5 or greater. Remember this rule? If this 4th digit is 5 or greater, then I'm going to round up. So I take my 3 digits, and again, to round to 3 decimal places means in the end I want 3 digits. 1, 2, and then a third. But that third one has to be rounded up to a 7 because the 4th digit is 5 or greater. Remember that? Alrighty. Now, also, to complete our table there, we're going to turn that guy into a percent form. So remember this? Take 0.267 and take the decimal place 2 places to the right, and you get 26.7, and then make sure you add that percent sign at that point. Multiplying the decimal 0.267 by 100 will get you that, right? And write it very clearly, 26.7%, right on in there. Go ahead and finish the table, pause me down, and come back to me when you're done with it, and we'll see if we can compare. All right, so here are the rest of my values. You will notice that I used the approximately equal symbols, approximately equal, every time I needed to round. Get into that habit. If you round, write approximately equal. It's just a very good habit. Whatever math you're doing, write that in. On the third one for red, I actually got exactly 0.2 when I divided 9 divided by 45. So you'll notice the equal sign. So there's a difference. Use it. It really does help keep straight what's going on. You'll also notice that 0.2 got me 20%, and technically it's 20.0%. There really is a difference, believe it or not, between 20% and 20.0%. It's a matter of accuracy, but MyMathLab really won't hold you to that line. So if I were to have put 20% in there, that would have been fine. For that matter, that's really 0.200 there for the same reason. Now, back here on this thought bubble, it says, what should these relative frequencies add up to? Do they? Think about that. Hopefully, maybe you did. They should add up to, think about it, 45 over 45, right? And it should add up to 100%. And in fact, these do. I actually did add up those numbers. They really do add up to 100%. But just be aware that sometimes it'll say it'll add up and it'll be like 99.9 or 100.2 or something like that. And that's just a matter of the fact that you rounded intermediate answers. You rounded these answers up here. If you're very far off, if you add these answers and you get like 105%, well, then maybe something's wrong, right? But odds are, if you're close to 100, then nothing's out of kilter, and not to worry. Okay, so here's our definition of a bar graph. It's constructed by labeling each category of data on either the horizontal or vertical axis with the frequency or possible relative frequency of the category on the other axis. Once we draw a bar graph, I'm sure you're going to be like, yes, that's what that is. I mean, it's pretty standard guy here. The height of each rectangle represents the category's frequency or possible relative frequency, if that's what you do. So on number 3, I ask you to just practice drawing a bar graph. So here is my axes, and I want to make sure I label those axes and put nice tick marks down the way. So, and provide a title. That's a really good one. So, okay, we'll put color down here and then just some equally spaced tick marks here to represent the colors. And just abbreviating however I see fit. That's good. And then we'll write frequency or count if you want up there. Now, for the scale on the y-axis or that vertical axis, I look back at my table and I notice that my values go from about 3 to a maximum of 12. So I'm kind of thinking, well, that should be easy enough to do. 5, 10, 15. That'll get me there. And again, I'm trying to equally space those tick marks so the thing looks relatively nice when I get done. And simply put, I'm going to estimate the 12 on my vertical scale and just draw up a bar above the brown. And that's supposed to look like a rectangle, and it mostly does, so good. And I'm going to draw my bar for yellow. And I want you to notice that there is space between these bars. That is important because when we get to histograms, there won't be any space. So make sure that your bars don't touch each other. Go ahead, pause me down, and continue with this, and then you and I can compare. All right, so there's mine. And oh my, if, I've seen some students, it just gets so beautiful with their colors and their going-ons. And so if you want to do that, fabulous, have at it. I think I'm running out of colors here, so that's all the colors I'm going to get done. But you get the idea. You can pretty it up if you want. But definitely recognize that this is a bar graph. And, just kind of remember back from wherever the heck you might have learned this before, how to do this. So one thing that we talk about down here is if you wanted to show not the frequencies or the counts, but you rather wanted to show the percentages, you could easily do that as well. And it's kind of cool because you'll notice that no matter if you use counts or the relative counts, the bars are going to be the same relative to each other. In fact, take a look at this now and then poof, I've changed it into relative frequencies. And all I did was I changed the title, the axis label, and these numbers here. But you'll notice the bars are still the same. So that's kind of cool to know. There's another little bit of, kind of maybe more trivia than anything. This is a Pareto chart. It is simply a bar graph where you see the bars drawn in decreasing order. So you sometimes see that in bar graphs. And now look at that. We have a name for that type of chart. Awesome. Much of what we want to learn in Math 145 is not just how to present data, but also how to consume it, right? How to read it. What in God's name are we talking about up here? And that we have to practice. So why don't you pause me down, try to answer those questions, and then come on back and we will talk. First, let's talk about this that might be a little confusing to you. This is not the summary of all the students' report cards. What this is some sort of diagnostic that was employed to evaluate a school as a whole. And they were given a report card, meaning simply, how is this school doing? So you'll notice that the axis down here is labeled number of schools. So this would be meaning 46 schools failed to meet expectations and so forth. Okay, so what does this graph display? Part A asks, and I just wrote how well public schools in Milwaukee are performing in 2016 to 2017. So that's pretty straightforward. And then part B, how many schools meet expectations? I am looking for the exact quote, meet expectations, and that happens to be up there, the third bar. So that is what I got there. Part C says how many schools score at meets expectations or above. And so you've really got to get into the nitty-gritty of their graph there and recognize that we are talking about meeting expectations that we had for the last part, and also exceeding expectations, which you see right above that, and also significantly exceeding expectations. So that's those three numbers, 29, 25, and 5, that I added up to get 58 schools. And by the way, you will notice that I bother to write down the word schools after that. Whenever you're answering a question, give the number, great, but also give the units. And in this case, it's schools. What are we talking about? 58 what? We're talking about schools. So make sure you give that information. It's almost as important as the number itself. In fact, maybe more so. Letter D. It says of the 157 schools represented, what percentage fails to meet expectations? And once again, I put that in quotes so that you would know that you're looking for that particular phrase. And let's write it over here. That looks like there is just one bar here, 46 schools out of 157. And so when I do my math, I divide those two. I did round. And so please, when you round, put an approximately equal sign. And then the next thing I want to say is that it says round to the nearest tenth of a percent. That tells you two things. Number one, they want a percent sign in the answer. And number two, if I'm going to round to the nearest tenth of a percent, what that means is that I need a whole number and then point and then a decimal, and when I'm in percent form, which means when I round my decimal answer, I am going to take 3 decimal places, so that when I move that decimal place over 2 places, I will end up with 29.3%. So that's the nearest tenth of a percent. Make sure you know how to round to those kind of instructions, because they come up a lot. Okay. All right. This is kind of a fun little one. Side-by-side bar charts give you lots of compact information. So consider, as this says, what this graph down here provides, and go ahead and answer number 5. Pause me down and see what you get, and we'll meet back up here. Okay, so for part A, it asks me what country and year do we see the highest birth rate given on the graph. What is that birth rate? So I am looking for the tallest bar that I see, and it is right here. And it looks like it corresponds to the Philippines in 1990. And then I ask myself, what is that birth rate? And so I follow over there. And as best I can say, to the nearest whole number, I'm going to go with 33 births. And notice how I wrote my answer, per 1,000 people. And I'm really just getting that from that label over there on the axis. What that means is for every 1,000 people living in the Philippines at that time, 33 little new babies came into the world in the year 1990, right? Okay, part B says describe the trend over time for the country of Malaysia. And so here I'm finding Malaysia, all 3 of these bars. And again, the first bar, the blue one, is for 1990, and then the red one is for 2000, and then the green one is for 2008. And so the trend over time certainly appears that's going down. So I wrote birth rates are going down, or decreasing over time is what I really wrote. Okay, part C. Who has the higher birth rate in 2008? Indonesia or Malaysia? Let me erase all that other stuff in there. And now I will think about 2008. So I've got to only deal with that green bar, and I'm talking about Indonesia and Malaysia. So I'm going to compare that green bar and that green bar. And it sure looks like Malaysia beats out Indonesia by just a tick, right? So I'm going to go with Malaysia there. All right, we're going to move on. We're going to see a topic that has to do with this sentence here. You'll notice that we are using relative frequencies or birth rates, and we're going to see exactly why on the next page. Go ahead and read over number 6 and then fill in these birth rates, and then think about the actual question, and pause me down, meet me back here. All right, for this number 6, first of all, I pulled from the 2008, which was the green bars, right, that we talked about in number 5C. I pulled the actual numbers. Well, I estimated from the graph. That's as best as I could do. Looked like Indonesia, I estimated at about 18. If you're somewhere in that area, great. Malaysia looked to be slightly over the 20 mark, so I put it at 20.5. But if you said something in that area, fabulous. Now from these numbers, you see Malaysia has a larger birth rate, which is important. But think about this. If we use numbers of births to compare, Indonesia actually looks like it has a whole lot more. If you actually just compare the number of births in Indonesia to the number in Malaysia, and it appears as though Indonesia beats them hands down, right? But when you look at their populations, you see why Indonesia has so many more births. Look at that. Their populations are different by a magnitude of 10, right? Almost 10 times as many people in Indonesia as there are in Malaysia. They are a much more populous country. So of course they would have more births. By looking at birth rates, in this case per 1,000 people, we are able to actually compare countries with very, very different population sizes. And that's a very important thing to be able to do. Okay, finishing this guy up, we have the definition of a pie chart, which you'll remember is that circle there, and you've divided into sectors. Remember that? And drawing it by hand is kind of a pain in the butt. So I show how to do it in StatCrunch. Sorry about that. I show how to do it in StatCrunch. So the instructions for doing that in StatCrunch are on the next page. All right, up above here you see our instructions for doing the pie chart in StatCrunch. The one thing that might really cause you trouble is when you choose the type of pie chart, you're going to have to choose with summary for this example. And the reason is because with summary means that you have a column with the colors and a column alongside it with the number of M&Ms of each color. For instance, we had 12 brown and 10 yellow, right? There is an option that's with data. Now, I don't want that here, but if I did just input the data from, say, the first page, and I just had one column just full of colors like brown, 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 red, red, yellow, orange. Remember that from page 1? Then I would use with data. But here, of course, I'm doing with summary because that's the type of data that I'm going to enter. So let's play the video and see if I can notate it a bit and try to talk through it. So we're going to start off with StatCrunch over there on the left. And when that opens up, you're going to see Visit StatCrunch website. Oh, dang it, that goes away. And then you're going to see Open StatCrunch there. And it takes a couple, honestly, I've had to hit that twice to get it to work. Here we're, oh, dang it, here we're labeling the variable one label color and then putting in our colors. And then I'm about to label var2 count, and basically reproducing the table as you saw it on the last page. So that's what's going on there. Okay, now graph, pie chart, and then with summary was chosen. I'm putting the color in, and then right here I'm putting the count in, and then down below and putting the title in. I don't type very fast. So there's my title, and now I'm going to hit this compute button down here at the bottom. Dang it. Okay, and there it is. You might notice it's a little weird looking because our categories were colors. I cannot find a way to tell StatCrunch that it should assign the colors I want to each piece of the pie. So that's a little awkward. The orange is colored yellow, the yellow is colored light blue, but of course that wouldn't matter if your categories were not colors themselves. So, but that's pretty cool. That makes a nice, accurate, and presentable pie chart. And I suggest, maybe this semester, if you've got a psychology paper or a biology paper that you need to do, go ahead, put your data in StatCrunch. Try to make some data displays.